A short information about logarithms. John Napier coined the word logarithm. Logos means a Greek word which means ratio. Arithmos, Greek word which means number. And logarithms was invented during the advent of Industrial Revolution. So now let's go to the concept of exponential and logarithmic forms. Logarithmic form we can convert into exponential form and vice versa. So it means exponential form we can convert into the logarithmic form. For instance, we have the equation log base b of m is equal with n can be converted or is equal with the base in exponent n equal with n, or base in exponent m equal with m is equivalent with the log base b of m equal with n. So let's just read about this definition here. Definition. The logarithmic function n equal with log base b of m is the inverse of exponential function m equal with the b in exponent n. What does it mean? The logs are inverse of the exponentials, and exponentials are inverse of logs. For this one, we're going to talk a little later in a different video. Logarithms. Let's go with one example. Explain. Earthquakes make a seismic wave through the ground. The equation y is equal to 10 in x relates to the height of amplitude in a microns of seismic wave, which we can write with a y, and the power or magnitude x of the ground shake it can cause. Describe how you can express the exact value in the third row of the table. So the question is how we can find out the magnitude x here if we know the amplitude y is equal with 5500. So just let me give a little brief explanation about when magnitude is 2. For example, y, if it's magnitude 2, 10 in exponent 2 is 100. So that's what we have here. And for instance, if let's say magnitude x is 3, instead of x here, we plug 3 here, and 10 in exponent 3 is 1000. That's what is here. And if the exponent x is a 4, so 10 in the fourth is a 10,000. But here we don't know what value of x is going to give us 5500. So how we can solve it? So first of all, let's try this equation, exponential equation, to convert into the logs or logarithms, logarithmic form. So already we see how is the conversion of logarithmic form or exponential form to logarithmic form. So the base here becomes a base of in the logs. So what does it mean? It means we can write as a log and log here, and we already base is a 10 of the exponential form. So base in logarithm goes here. The base is here 10, and y stands here y, and exponents goes in other side. So exponent x is here. So now already we converted the exponential form into the logarithmic form. So now just let's see here. Y, for example, in the third row was 5500. So log 10, log of a base 10, log base 10, and instead of y we write 5500, 5500 is equal with x. So now we have to find x. So log of base 10 of 5500 is equal with x. So now we can go in a calculator, and if we go in a calculator here, and let me take out this number, and here is the amplitude, or y is equal with 5500. We write this 5,500. And here we have a log base 10. So we touch log base 10, which is 3.74. So x is approximately, because there were a lot of other decimals, is approximately with a 3.74. 74. So we already got. So instead here in the third row, the x is going to be equal to 3.74. But if you look closely, between 3 and 4, we already know, because 5,500 is between 1,000 and 10,000. So it's between 3 and 4. If we look closely, 5,500 is in the middle somewhere. So between 3 and 4 should be 3.55 somewhere. But if we are doing a calculation, we find a more exact value, which magnitude x is equal to 3.74.